All right, good day and welcome back to Everything Mathematics. And today, with no further ado, we're going to go straight into Rule 1. Well, officially, Rule 1. We have been looking at various concepts before. Today, we're going to go straight into Rule 1 when dealing with logarithms. And when dealing with logarithms, Rule 1 says this, and I'll write it in one of two ways because both ways are important to understand. Rule 1 states that if we have a log of a certain base, of something. So let's say log A of B, and we are adding that to log A of C. Should I put C or should I put another? Yeah, let's put C. According to rule 1, this states that this can also be written as log of A, and you take the product of whatever it is that you were adding. So in this case, it will be B multiplied by C. This is basically rule 1 when it comes to log. But right away, I want to emphasize one thing. Notice that for this rule to be applicable, you have to have the same base. So simply because this is base A and this is base A, then this rule can be applied. We can take one log of the same base and we find the product of whatever it is that we were adding. The reverse of this rule is also true. So for instance, if you have something such as log B, same B or P, let's leave P, doesn't matter. If you have log P of, let's say, two unknown things, let's say X multiplied by Y. If you have this can easily also be written as log, because both of them are under the same base, log P of X plus log P of Y. Good. So this is one of the first principles under logarithm, or rather one of the first rule, which simply states that the product of two logs can be added, or when the sums of two logs can be multiplied, so long as the base is the same. If the base is different, then this law or this rule cannot be applied. You will have to do what we call a change of base first. And when you apply the change of base, then you could apply this rule if still applicable after you change the bases to be the same. Good. Under this rule, of course, it's just a matter of understanding it and being able to apply. There's only one of two things they could ask you here. They could either ask you to expand or they could ask you to solve. Oh, and of course, they could ask you to maybe write as a single log. So, and which is basically the opposite of expanding. So let's see if we could just do one or two examples how this rule can be applied. And then after, we're going to call it a video. So let's look at an expansion problem first. So first of all, as I said just now there, one of the things I could ask you to do in terms of applying this rule here is that of expand. And under expansion, of course, I might give you something in the fashion of, let's say, log of 2, and in bracket, you might have what? Something like, let's use algebra, 5a. Yes, let's work with this one first. So if they give you something like this and they ask you to expand, of course, it's just a matter of understanding rule 1. So this here, we could actually do this in one fell swoop, but let's see if I could maybe do it in 2 parts just for us to understand what is happening. So here, of course, the first thing, oh no, actually by the time I'm done here, we have it. The first thing we should do here or see here is that 5a is the same thing as 5 multiplied by a, and that could also be so easily this, guys. So according to the rule, this simply states that this would be equal to log 2 of 5 plus log 2 of a. And that's it, problem solved. So this is what we call an expansion situation. Of course, if your calculator is advanced enough, you could go one step further here maybe. I would not, I will leave it at this. But we could easily find what is log 2 of 5 in some scientific calculators. And this will be a number. This will be some number. So it will be that number plus log 2a. With log 2a, there is nothing much we could do, unless, of course, they give us some other additional information that we say, supposing we know this is equal to something, then yes, we could find a. We could solve for a, you know, like make a the subrecurrent formula. But as it is here, no, log 2,5 will be some constant. So let's say maybe some constant b, some number, and that will be plus log 2a. And that's as far as we could go. I'm only using b here to substitute whatever log 2,5 would be, which you could calculate via calculator. But remember, it's log base 2, So if you just use log like that, oh, and as I said that, I might as well say this. In your calculator, you do have a function for log, but in your calculator, your log is actually base 10. So that's one thing you need to know. So if you put log of 5 in a calculator, it wouldn't be the same result as if you would have had log 2/5. Some calculators, of course, they have this button. They have a log and a little triangle below it. Not triangle, a little square. If you have this button, when you press it, you'll be allowed to put whatever base here. And of course, then you have a bracket here where you will put in your 5. And if you have the little square, you could put in 2. But not most calculators have that. If you have an advanced calculator, a good enough one, you might have this option. And that's how you deal with finding log. So yes, log is an actual number. Don't think log is an abstract maths, whatever. It's an actual number. Remember, as I did in last week's video, log is just a way we use in which we represent a very large number in a condensed manner. That's what logarithm do. But of course, if you go to find the log of it, you will get a number. Sometimes a very long decimal. Oftentimes you might be asked to round off to, a certain amount of places. Or sometimes you just leave it as a log. Leave it as a log. That's usually what is being mostly tested. Good. Let's try another example. So sometimes we could get something like what? Let's say log of, let's say log base 6 of, let's use some algebra again, PBC, which is actually the name of a school here in Grenada. Right, so yes, but again, we have to see the algebra here. And what is really taking place here, the P is being multiplied by the B, which is in turn multiplied by the C. And we were asked to expand. So when we expand in this, we have to be able to see this as log 6 of P plus log 6 of B plus log 6 of C. Good. And sometimes I've seen cases where people put this in brackets for the sake of separation. You could do that too, but it's not necessarily a must. I think what is more important is to identify that log 6P is an entire entity. That's what I think is most important, because sometimes you cannot see the log 6P as an entity, log 6B as an entity, and log 6C as an entity. So these are two basic examples when it comes to expansion. And notice when it comes to the expansion too, there's nothing much here really. You just have to know the rule. In fact, one rule in isolation is usually not tested. Usually you tested. When you're tested, you have to apply maybe at least 2 to 3 rules in order to simplify or solve a problem. Let's write as a single form now. So the other possible way you could ask to do log, they could ask you to write as a single log. Write, put WI, write as a single log. And that's also sometimes something that you could be asked. And if they ask you to write as a single log, more than likely that means you would be given an expansion. And let's just do one here. So for example, I could give you something like maybe log A of 3 plus log A of 4. And let's leave it like that. So let's leave it like this. This one will be a little interesting because we'll actually get a result. So log A of 3 plus log A of 4, we have 2 different logs. If we write in as a single log, it simply means that there must be 1 log. Notice here we are adding 2 log entities. So because we're adding 2 log entities, we could apply the rule that says, of course, the sums of 2 logs, so long as they have the same base, is equal to the product of the logs. So that would be the same as log of A, and we add whatever we were logging. We multiply, sorry. In this case, it's 3 times 4. And of course, that would be the same thing as log A of 12, since these 2 numbers can be solved. Of course, sometimes you have to be very, very careful with simplifying. I went ahead and simplified here. But you need to be very careful, because sometimes if we have to revert it, and that's one of the things you always have to bear in mind when doing maths. If you could go this way down, you have to be able to go back up and get back the same thing. Very crucial and important when doing maths. As a result, when you multiplied out here, sometimes you could lose track and forget what you had the step before. If we go to reverse this log, let's say to get back this here, not much persons would have known initially that was 3 and 4 we multiply. Yep. In a case like 12, what if we had 6 times 2? Or what if we had 12 times 1? They're all plausible situations. But again, maybe I'm thinking too critical here too. So yes, I think that's where we're going to wrap it up for today when it comes to rule 1. And I will play more with this rule, but as I said, it gets more interesting when you know more rules. Just one single rule, there's not much grounds for playing. And by playing, I mean doing some intricate and solving some more complicated questions. So, but I trust this rule was clear enough for you today. And in the next video tomorrow, God willing, we're going to look at rule 2. And as we build up on the rules, of course, we're going to see if we could do more complicated questions. So until then, as always, feel free to like, share, and subscribe if you haven't as yet. And until the next one, you take care.